Operating system will going to take care about all the different kinds of files that we have in a computer system. If I am storing information about metadata along with the relational schemas, then we are groupingly or together we are calling that as a data dictionary, or it will be considered as system catalog. With the help of the search key, we can find or we can access the records array tuple whichever is required from the relation. Everybody, a warm welcome to one and all. Welcome back to the session 6 of Unit 4, and we are in the B.C.A's 4th semester subject called Database Management Systems. In short, it is Dbms. I am Rohini TS, Department of Computer Science, Vidhyaashram, 1st grade college, the Temple of Excellence, MYSURU. So in our today's session, we are going to dealing with this indexing concept. Before that, we'll discuss a previous class content here. That is what recap. So in the previous class or previous session of this unit, we have discussed regarding the storage strategies. So once we got the data or once we got the view of old database, then it is necessary to store that data. For that, we have a different kinds of methods. In order to store the data, it can be a primary memory, secondary memory, or a tertiary memory. That is what I have discussed along with the device hierarchy. So which is at the topmost, that will be more fast and it will be costlier. When it comes to the lower level, it will be slower in accessing the content from the disk, and it will going to somehow cheaper than the previous types of storage devices. And also I have discussed regarding this RAID, that is redundant array of independent disks. So in our today's session, we're going to see how this file organization will going to take place, why file is required, and then organization of records in a file, and also we're going to see about this data dictionary storage. All these contents are very important question for 2 or 5 marks question, and also we're gonna discuss regarding this indexing, B plus minus tree, and at last we'll see about this hashing. So in our today's session, first we'll discuss regarding this file organization in the Dbms. So here you can see that database is mapped into a number of different files that are maintained by underlying operating system. So operating system will going to take care about all the different kinds of files that we have in a computer system, and also these files will going to reside permanently on the disk, as we all discussed earlier. So whatever the data or whatever the content we have on a database, everything will be in the disk or a magnetic disk. From there we have to retrieve it or access it for the processing. Once it got processed, again it needs to be right back to the disk only. So you can see that all the file will going to be stored in the disk. And also a file is organized logically as a sequence of records. So it will be a file is nothing but what? It will be a sequence of record. So each record already you know about that, right? So row of a table is considered as a record here. That will going to have a unique value from one record to another record. It will be a sequence of records, and these records are mapped onto a disk blocks. So how it will going to be mapped? It will be mapped to the block of a disk. So with the help of this, we can fetch the content whatever we have in a file, and all these blocks are the units of both storage allocation as well as data transfer. With the help of this blocks, that blocks will going to act as storage media. Along with that, it will going to help us in order to have the data transferring. So this is what file organization. Then how we are going to organize the records in a file? So you can see here, a relation is a set of records. So how can I say relation is a set of records? It will be like this. So if it is a collection, then we can call this as a relation. If it is a collection of relation, then our logical ordering or logical sequence of relation, we can say that as a file. So here we have a different methodology in order to do the organization of a file. Amongst that, first we have a heap file organization, then we have a sequential file organization, we have hashing file organization. So when it comes to the heap file organization, here any record can be placed anywhere. So randomly we can place any of a record anywhere in a file. There will be no restriction. Wherever we have a space for the record, there we can store that. But there is no ordering of record here. So we are not going to maintain any numberings or ordering, ascending or descending. All those things is not going to be entertained in this heap file organization. Randomly we are keeping the records or reports anywhere in the space wherever it is free. And also there is a single file for each relation. When it comes to the relation, each relation will be managed or handled by this single file. All the single file will be stored for each relation. That is what heap file organization. No restrictions over the organization of a file. What about the sequential file organization? Records are stored in sequential order. It will be in some order. So it will be in the linear format according to the value of a search key. So based on certain parameter or based on certain arguments, that list or that particular records will going to be stored in some order of each record. That type of file organization is considered as sequential file organization. At last we have a hashing file organization. So in this, it is computed on some attribute of each record. So in order to find the uniqueness of a record or a tuple, we require an attribute. So if I am finding or if I am organizing based on that attribute or a field, then we are going to call that as a hashing file organization. The result of the hash function specify in which block of the file the record should be placed. So it will going to specify the block of a file where we are supposed to keep that record or where we are supposed to keep that collection of records or a sequence of record, that is file itself. These are the three types of organization of a file that we have in a DBMS. So next we see about this data dictionary storage. All these are very important question for 2 marks. So define data dictionary, define metadata, define data catalog. All those are one on another way same. So you can see the definition here. A relational database system needs to maintain a data about the relations. That relation data includes schema of a relation. Already you know what is schema, and it will going to called as a data about data. So if you are storing the details about the schema, anyway schema is a skeleton structure or it is a representation of a database. It will going to have all the content in the representation of a schema. But if you are keeping details regarding the schema, then we can say that as a data about data. We can consider that as a metadata. Very important question for 2 mark. Define metadata. What it is? A relational database system needs to be maintained data about the relation. That relational data includes schema of a relation. So we are going to call that as a data about data. We call that as a metadata here. Next, relational schemas and other metadata about relations are stored in a structure called the data dictionary or system catalog. Anyway, we are storing a detail about a schema, that is metadata. If I am storing information about metadata along with the relational schemas, then we are groupingly or together we are calling that as a data dictionary, or it will be considered as system catalog. All these terminologies you need to remember. Then what kind of data or information that it will going to hold? It will include the name of a relations. What is the name of that tables? So that relation name will going to be hold or will be kept with the help of this system catalog or by the data dictionary, and also it includes the name of the attributes of each relation. For each table, what is the field name or attribute name, and also that specifies the domains, that means specifies the range. What kind of value are we supposed to give? If it is what date of birth, then what kind of data it is taking? That specifies the domains, and length of the attribute, how long it must be. If I am specifying char of 5, at max it will going to hold only 5 character. That will be specified here, and also the name of views defined on the database and the definition of those views. So if you are creating a virtual table, even that details will going to be stored in this data dictionary along with that integrity constraint. If you have any some standards or if any rules needs to be obeyed by the database, all these information together will going to be stored under this data dictionary or a system catalog. We'll see the next point. It will going to keep the data on users of the system. We have a users for the system, right? Then what kind of information about the user it will going to store? So under this data dictionary storage, it will going to hold the detail regarding names of authorized user. So when you are typing or when you are opening that command prompt, there we are going to use a username along with a password during your lab exams or during your practicals, right? That is matching whether they are authenticated user or not. So that name of authorized user will going to be stored here along with that authorization and accounting information about the user, like when they are logging in, what is their logout time, what are the resources they have used. All the information will going to be stored here along with a password or other information used for authenticated user. In order to find you as authenticated user, password and ID we require. That details is also going to be stored here along with the database, MYSURU, statistical and descriptive data about the relation. So the data dictionary is not only going to store the details regarding a user of a system or the normal information which is required. Along with that, it will going to store some of the statistical and descriptive data about that particular relation. So that statistical or this descriptive data includes the number of tuples in each relation. If I consider a table or a relation, how many tuples or a records or a rows that we have in each relation, that is also going to be stored under this data dictionary. Along with that, what are the method of storage for each relation? For example, whether it is a cluster method or non-cluster method, and data dictionary may also note the storage organization. What kind of file storage organization are we using? Heap, memory, sequential, all kind of information will going to be stored here. Along with that, of the relation and the location where each relation is stored. In order to get to know the memory address of each relation, that kind of information, everything will going to be stored under this data dictionary storage. And also, next we'll see about the next topic, that is regarding indexing. As of now, we got to know that what kind of storage we have, how records will going to be stored, how can I find the records then, if I wanted to access it or if I wanted to get the content from it, how can we going to access that too with the help of this indexing. We'll see the definition then. An index is a structure that helps to locate the desired records. It will going to help us in order to locate or to find out the required or desired records of a relation quickly without examining all records. So instead of checking each tuple or a rows, so we are directly getting the records or we are directly getting a tuple out of the relation. That methodology or that structure is considered as what? Indexing or index. So we have two kinds of index here. One is ordered index and another one is hash index. So as the name indicates, if it is ordered indexes, that structure will going to help us in order to fetch the record or in order to fetch the tuple in an order manner. It will be based on some sorted ordering of the values. For example, if I am storing a data about the student based on their register number, so that will be in order. So if I consider their age, there could be a mismatches of age. So some people will be in the age of 17. If you consider the higher degrees and all, at that time we can't bother about the age. So whatever the factor which will going to help us in order to make it in some order, then we are going to call that kind of indexing as what? Order indices. And also next we have a hash indices. Here it will be based on a uniform distribution of the values across a range of buckets. So you will be knowing about this buckets in my coming slides. So as of now, here we have some uniform or same kind of distribution of values across the range of buckets. So that buckets will going to help us in order to find the values whichever going to be stored there. With the help of that value, we can find the records in a fastest manner. So for that reason, we are going to have some hash functions, or we are going to use some of the functions in order to determine that. That will be considered as what? Hash function. So we are using certain function in order to find the values whichever we have in a bucket. So that functions are called what? hash functions, and if you are using some structure in order to find out that records are a tuple in the quick manner, then we will be calling that as a hash indices. So with the help of these two methodology, we can get to know or we can access the records or a tuples in a fast manner of a relation. So next, what are the factors that we require in order to evaluate the indexing? That means whether I should go with the sequential indexing or whether I should go with the hash indexing. So based on certain parameter, we are going to evaluate it. How fastly we are getting a data, what is its access time, how much storage space it is taking. So here we have certain parameter access type that specify a type of accessing. Are we doing it randomly or in a sequential or some logical order? And also how much time it is taking in order to access that records or a tuples, and insertion time. If I wanted to add a new record or a tuple, how much time it is taking, along with the deletion. If I wanted to delete certain rows or a relation or a record immediately, how much time it is taking, along with a space over it. So mainly we need to concern about the space as well as the time. So by considering all these factors, we are going to evaluate whether I should go with ordered indices or whether we should go with the hash function or hash indices. So these are the factors we have. So we'll see the next point here. Sometime we wanted to have a more than one index for a file. So why? Because for the more convenience, or if I wanted to access the content immediately, at that time we may require more than one index. So there an attribute or a set of attribute used to look up records in a file, then we are going to call that as a search key. So if I am using certain parameters or arguments, or if I am using some of the field name or more than one field in order to find the uniqueness of a record, then we are going to call that as a search key. So that will be a collection of an attribute or a set of attribute which will be used in order to look up the records or to find out the tuples in a relation. So for that reason, we are going to call this as a search key. With the help of this search key, we can find or we can access the records or a tuple whichever is required from the relation. So next we'll see the next topic, that is regarding B plus minus tree. So what about this one? You can see here most of the relational database. So if it is a relational database, everything will be treated as a table. If it is a table, then it will be a collection of rows as well as columns. Rows are records and columns are tuples here. So in this relational database, restrict the size of a record to be no longer than the size of a block. So if it is my block, so if it is dealing with a relational database management system, at the time the size of a record or the number of records or tuples, whatever we are going to insert for the relational database, that should not be greater than, or it should not extend the size of the block, right? So it should not expand or it should not be greater than the size of a block, mainly to simplify the buffer management and free space management. So if it is restricted under within that block or a bucket, then it will be helpful in order to do or to have this buffer management and free space management. So for that reason, we are going to restrict here. So with regard to this first point of this B plus minus tree content, so here we should not have a record or a tuple which should be greater than the size of a block. So what if we have a large object? So sometime we are going to store this large object with a special file, right? Or it can be a collection of files instead of being stored with the other attributes of a record. So if I have a large objects which consist of properties as well as methods, so instead of storing it in the normal or with other attributes, we are going to store it with a special file in which they occur. So here what it means? So we have a large object, instead of storing it in the record, we are storing it in a special file. So in that record it will remain blank, right? So for that reason we have one pointer. That means we have a address of a large object where it is stored in a special file. That is what you can see here. We have a logical pointer to the object that is then stored in the record which is containing the large object. So instead of storing a large object as an attributes of a record, we are storing it in the special file. So if I wanted to get to know where do I have that record in a special file, then we are going to use this logical pointer. With the help of this, we can find the large object wherever it is storing. So here the large objects are often represented using B plus minus tree file organization. Then how this large objects will going to be organized, that too with the help of this B plus minus tree file organization method. So it permits us to read an entire object. So I can read an entire object, but that is not possible whenever we are restricting the size of that record within a block. But if it is storing under this B plus minus tree file organization, it will going to allow us in order to read a complete or an entire object can be read or specified byte ranges in the object, as well as it will help us in order to insert and delete the parts of the object. If I don't require any of the parts, or if I don't want it to have certain properties or a methods for a particular object, even that can be easily added and removed whenever it is presenting or representing with the help of this B plus minus tree file organization. We'll see the next and last topic here, that is regarding hashing. So here we are till now we have used certain logical methodology or sequential ordering or linear ordering methodology is there in order to fetch or to access the content of a records or a tuple. But with the help of this hashing technique, it will going to help us in order to calculate the direct location of a data record on the disk without using index structure. So here, instead of bothering about where it is locating and all, we are directly getting its location or direct location of that data we are getting of a record. That method or effective technology is considered as what? Hashing here. So hashing uses hash functions. So that function will going to help us in order to find the perfect or a specified location or a direct location of a records data with search key. So we are going to use certain parameters or set of attribute as a search key here to generate the address of a data record. So in order to get to know or in order to find out a particular data record, we are going to use certain columns or a field. So that collection of fields will going to have certain functions, that is considered as what? Hash function. With the help of this hash function, we can directly fetch its location of a data records. So this will going to be more efficient than this index structure methodology. So here we are going to have two methodology, or it will going to have two elements here that consist of bucket and hash function. So what about this bucket? What do you mean by it here? A hash file stores the data in bucket format. It will going to stores the data as a bucket format here, and bucket is considered as a unit of storage. So mainly this bucket will going to help us in order to store certain information, and bucket typically stores one complete disk block. So this will going to have a ability to store one complete disk block of data, which in turn can store one or more records. So each bucket will going to store one or more record. So I can directly get to know the accessibility of each bucket. So it will be a collection of bucket, and directly we are going to have an accessibility to this bucket. So whatever the records or a tuple which is there in the particular block of a bucket, then it will be easy in order to find out its location. That is what the reason. Instead of making some ordering or instead of using some indexing methodology, we can have a direct access to the location here. Along with that, with the help of this H or hash function, we are finding the immediate, or we are accessing the direct location of a data record here. So hash function called H is a mapping function that maps all the set of search key K to the address where actual records are placed. So if I am searching for a Java, so at that time, with the help of this hash function, it will going to search in all the buckets, or it will going to search with the records or wherever the actual records are placed. It is a function from search keys to bucket address. So we are going to have a hash function in between. So with the help of some search keys, I am going to find the address of a data records which is going to be present in the bucket address. So you can see that here I have certain search keys 100, 101, 102, 103. So with the help of this hash or hash function, I can find the data records which is present in the data bucket. So if I say 100, then that will going to directly specifies the database. If it is 101, it specifies C++. And if it is 102, I will directly go with iOS. 103, then HTML. So instead of checking every index or instead of checking every data record with the help of this search key or with a collection of attribute or a set of attribute along with the hash function, directly I am fetching the location of the data elements whichever we have in a data buckets. This will be more efficient way in order to find the location or to get the access for the data records in a relation. This is regarding hashing. I hope you all understood. In my coming session and last session of this unit, we will be learning regarding OOD, that is object oriented database, and also I am going to discuss regarding object oriented relational database, and also we'll see what is this logical database and distributed database, data warehousing. At last, we'll see about the data mining in the last session of this unit. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.